Okay, well, okay. Shh. So FOIL, when we're talking about FOIL, this is another form of multiplication. What we've done, you've multiplied where it's just two radical values being multiplied together, or three radical values being multiplied. You've done the problem where you have a single radical outside of a radical addition or subtraction problem where you had to distribute. FOIL is a form of distribution where you're multiplying two quantity values of addition or subtraction. So when we're talking about two-termed quantity values, we're meaning things like binomials. You've got two terms that are being multiplied to each other. And the process of distribution, because all it is it's distribution, so you're taking your first set of quantities and distributing each of them to the second set of quantities, but we call it a FOIL method. So FOILs stands for first, the F is first, which essentially just means it's the first value inside each parentheses. The first value inside each of the parentheses. The O stands for outer, and that's based off of the entire problem. So if you're looking at the entire problem, it's your first and fourth values. It's your first and fourth values when you're looking at the problem as a whole, not just each individual parenthesis set, but the whole set. Okay? I is going to represent inner. That also is focusing on the entire problem. And you're going to work with the second and third values. Again, when you're looking at it as a whole, the second and third values. And then when we talk about the L represents the last. So it's the second value inside each parenthesis set. It's your second value that's inside each of those parenthesis sets. And this is just basically telling you the order in which you're going to multiply and then combine things that can be combined. So let's take a look at an example. If I have a problem like 4 plus the square root of 5 inside one set of parentheses, and then inside the other set I've got 3 minus the square root of 5. 4 plus the square root of 5, 3 minus the square root of 5. So what this means that we're going to be doing is we're following the order that we have here. So the first thing is to identify our F. So F represents those first, the first value inside each parentheses. Who can tell me what are those values? Heaven? 4 and 3. So the 4 happens to represent a first, and the 3 happens to represent a first. So what I'm going to do for my F is I'm going to multiply 4 times 3, which is going to give me 12. Then I go to the O. O represents the outer. So looking at the entire problem, my outer values, or my first and fourth value, what are those? Mateo? 4 and square root of 5? Negative square root of 5? Got to make sure you include that operation in front of it. So it's 4 is an outer, and then the negative square root of 5 is an outer. So now we're multiplying. We're multiplying 4 times negative square root of 5. And that's going to give us a negative 4 square root of 5. Okay, now the inner. What's the inner values? Who can raise their hand and tell me my inner values? Grant?
5 and 3.
Not 5.
Square root of 5.
Square root of 5. Got to make sure you're understanding that. And it's a positive, focusing on the fact that it's a positive square root of 5 is an inner, and that positive 3 is an inner. So we're going to do the square root of 5 times 3, which is going to give us 3 square roots of 5. And then the L, the last. What are my last values? Kendall?
Positive square root of 5 and negative square root of 5.
Very good. That positive square root of 5 and that negative square root of 5 are both my last values. Okay, so we're going to do square root of 5 times negative square root of 5, which is going to give us a negative 5, right? Because it's negative square root of 25, which happens to equal negative 5. Okay, so now we've got the answers to all the FOILs. So what we're going to do is we're going to write this out as an addition problem where I'm combining my like terms. I'm focusing on combining those like terms. So out of these, which ones are like terms that I can work with? Grant?
Negative 4 square root of 5, 3, negative square root of 5, and the other set is 12 and negative 5.
Very good. So we have two sets in this case. We have two separate sets. We've got the 12 and the negative 5. Those can be combined together. Those are like terms. So I know I can take my 12 and I can combine it with that negative 5. So what's 12 minus 5 going to give me? 7. And then I've got, I'm just going to put a dot next to the ones that are also like terms. I've got negative 4 square root of 5 and a positive 3 square root of 5. So negative 4 square root of 5 plus 3 square root of 5 is going to give me what? What's negative 4 square root of 5 plus 3 square root of 5? Negative 1 square root of 5, or just negative square root of 5. And that's it. That's your answer. You're done. So the final answer is 7 minus the square root of 5. Huh? You had what? Did you say you don't like FOIL anymore? It's really, it's not too hard. It's just it's a step-by-step process. And they're not going to get any harder because I'm not going to give you any variables on this one.
Oh my God, bless your heart. I like how you again.
You're not going to have any variables on this one. However, you are going to have to show your work when it comes down to the test. You're going to have to make sure you show the step-by-step process, because the question might not just ask you, what's the final answer? It might ask you, what's the inner value going to equal? What's the first value going to equal? Not what the first values are, but when you do the first values, what does that equal? So like here, if I said, what's the inner value equal, you'd have to tell me it's 3 square root of 5. So you might have to answer that whole step-by-step process and then say what the overall answer is. So the calculator will help you to check, but it won't tell you what the individual components are. Arham? Well, I had a help session on Wednesday. Well, no, on the whole unit. Anybody who comes by, I help, and then I do help during the week via text. If it gets to a point that it's too complicated for you to understand via text, then that's when I say, can I call you or FaceTime you? And perfectly fine doing that. But it's hard for me to get in here earlier than Wednesdays. Wednesdays is my designated day to be able to come in, and my husband takes the kids. Okay? But you guys always have that option to message me for help, and I will. The only time I might cut you off is if I feel like I'm doing your homework for you. And there are times when it gets to the point that, okay, I've helped you with a lot of problems in class, and I've helped you with a lot of problems via text. You got to start doing that homework on your own. Okay? Yeah. In a situation, it could potentially ask you the question of what are each of the individual steps going to be, yes. But that would be obviously a short response problem. Now, there could technically be a multiple choice problem in which you have to pick out several options, click all that apply, where it might state, oh, the first values would equal this, the last values would equal this, here's what the final answer would equal, and you'd have to click all those components that would create the whole thing together. You do get a calculator for the test. Yes. Elijah?
Can the answer also be negative square root of 5 plus 7?
You could technically put negative square root of 5 plus 7 as well, yeah. Kendall? Because negative 4 plus 3 is a negative 1. So we're left with just a negative 1 of that square root of 5. Okay? All right, let's take a look at another. So now, problem like this is meant to throw you off because a lot of people automatically, they see that and they immediately want to do what? What do you think? They want to distribute it. Because in our previous problems, we were able to distribute it. But in our previous problems, did we have an addition sign or a subtraction sign in between? It was straight multiplication or single, a monomial type of value, and we were able to distribute that exponent to each of the components in that monomial. Here, this is a binomial with a power of 2. So it's a FOIL method. You just have to write it out. So instead of just having 9 plus the square root of 2 raised to the second power, you would rewrite it 9 plus the square root of 2 times 9 plus the square root of 2. Whoops. Okay?
It's like the whole problem.
Yeah. Okay. So let's identify our first. Our first is what? 9 and 9. Yep. So there's your first. Here's a first. What's 9 times 9? Okay. Outer. What's the outer values? 9 and that square root of 2. Outer and outer. So what's 9 times the square root of 2? 9 square root of 2. Good. Inner. Square root of 2, that's positive, and that 9. which equals 9 square root of 2. And then the last. What are the last values? Square root of 2 and square root of 2. So square root of 2 times square root of 2 is what? Square root of 4, which is 2, right? Okay, now let's focus on combining like terms. What's the first set of like terms? 81 and 2. So we're going to take 81, and 2 is positive, so we're going to add 2. So what's 81 plus 2? 83. Okay, what's my other set of like terms? 9 square root of 2, 9 square root of 2. So what's the 9 square root of 2 plus 9 square root of 2? 18 square root of 2. Oops. Let me rewrite this. And there's your final answer. 83 plus the 18 square root of 2. Or you could put 18 square root of 2 plus 83.
Is it gonna be like this every time where like the first and the last are added together, are added together and the inner and the outer are added together?
In these situations, yeah. You will have other situations that pop up, but not this year. All right. Try this one on your own. All right, you can tell me what they got for their final answer. Heaven? Very good. Negative 8 minus 2 square root of 7. So if we take a look at our first values is the square root of 7 and the square root of 7. So when we multiply square root of 7 times the square root of 7, that's going to equal 7, because square root of 7 times square root of 7 is 49, which is equal to 7 as a whole. Okay, our outer values, that's going to be the square root of 7 and the positive 3. So we're going to multiply the square root of 7 times a positive 3, which is 3 square roots of 7. Then we're going to multiply our inner values, which is a negative 5 times a square root of 7. So negative 5 times the square root of 7 is equal to negative 5 square roots of 7. And then our last values. Our last values, when we multiply, we've got negative 5 times a positive 3. Negative 5 times 3 is equal to negative 15. We know that positive 7 and a negative 15 are like terms. So if we do 7 minus 15, 7 minus 15 is going to give us a negative 8. Then we've got these 3 square root of 7 and the negative 5 square roots of 7. 3 square root of 7 minus 5 square root of 7 is going to give us a negative 2 square root of 7. And then that's our final answer. All right, let's take a look at another example that might be a little bit more difficult, but not too much more. Okay, if I were to give you negative 2 square root of 3 plus 2 times the quantity of square root of 3 minus 5. It's still the same exact process. What are my firsts? Good. Negative 2 square root of 3 and the square root of 3. So who can raise their hand and tell me negative 2 square root of 3 times the square root of 3, what's the final answer for that going to be? The final answer. What do you think, Mateo?
18.
Not 18. Chelsea? Not negative 18. Grant?
6.
Not 6. Annalise? Negative 6. Okay, so if you were to do this step by step, you could multiply the radicals together. That would give you a negative 2 square root of 9. Well, the square root of 9 is just going to equal 3, so now you have negative 2 times 3, which is equal to negative 6. Okay? Our outer, what are our outer values? Good. Negative 2 square root of 3 and a negative 5. Those are my outers. So negative 2 square root of 3 times a negative 5. What do we get when we multiply that? Which of the values can we multiply together? Negative 2 and negative 5. Right? Because both of those are not inside of the radical symbol. So we're focusing on actually multiplying those. So we're going to have negative 2 times negative 5, and then attach a square root of 3 at the end of it. So what is that going to give us? Nathan? 10 square root of 3. So we have 10 square root of 3 for that answer. Okay. What's our inner? 2 and square root of 3. right? So what's 2 times the square root of 3? 2 square root of 3. And then our the last values. 2 and negative 5, good. So what's 2 times negative 5? Negative 10. All right. Just a little bit harder, not too much. What's the components that we can combine? What are our like terms? Negative 6 and negative 10, okay? So if we take negative 6 and we subtract 10, what's negative 6 minus 10? Negative 16, good. What's our other like terms? 10 square root of 3, 2 square root of 3, good. So if we take 10 square root of 3 and we add it with 2 square root of 3, what do we get? 12 square root of 3, yeah. Positive 12 square root of 3. And that's our final answer. Okay, so let's go ahead and write down what you're going to work on for today. It's okay. I'm so sorry. Six problems, that's all you're going to have. 6 problems. Only 6. Shh. Well, just don't miss any. Now, here's the thing. I know you're thinking, oh, it's only 6 problems. That means, again, if we miss something, it's going to take a lot of chunks off. It's not, because I want you to show your work, because each problem is going to be worth 5 answers.
Wait.
Your first, your outer, your inner, your last, your final answer. Is that understood? So it's really 30 questions. But one question's worth 5 alone, okay?
Think about it.
Shh.
I mean, it's only worth 3 points.
So that's the thing, because a lot of people, let me tell you my reasoning for it. A lot of people are okay with this portion right here. They're okay with this portion. It's when they have to combine that they sometimes mess up. I don't want you to miss an entire problem when you might have done steps, you know, maybe you got the F, the O, and the L correct, but you messed up on the I. Well, then at least you've gotten 3 points out of there instead of having everything lost, okay? And I won't do, maybe I'll just do 5 questions. 5 questions, okay? Shh. Okay.
Do we have to do it in color? Can we just do it in pencil?
Do whatever you want. Shh. Like I said, you can to check it, but the calculator's only giving you the final answer. It's not going to tell you what the FOIL, the outer, the inner, or the last values are. It's just going to solve the whole thing, which means that you would miss 4 out of 5 points on each question. right, there's your homework. Huh?